guys.
Hey, rock on.
All right, everyone. Welcome to ATARC's Data Analytics Lab presentation, where we'll hear from our presenters as they discuss the research and findings done by our Data Analytics Lab team. ATARC stands for Advanced Technologies Academic Research Center and is a nonprofit that facilitates collaboration between government, industry, and academia in order to accelerate technology modernization initiatives. We provide ongoing opportunities for cross-agency collaboration through on-site interaction, learning, and market research. So welcome to all the attendees. Thanks for joining us today. Before we begin, I do want to encourage anyone in the audience to submit questions of your own, if you have any, into the Q&A section of this platform. And our presenters will be going through them as they do their presentations, so please send them in. And now I'd like to pass things over to Rajan Srivatsan, the vice president, of civilian sales on the public sector side at SymphonyAI. Raj?
Perfect. Thank you so much, Nicole. Thank you all for taking the time to attend this event. My name is Raj Srivatsan. I'm with SymphonyAI's public sector team, and I'm responsible for managing our business with federal civilian agencies. With me, I have Eric Murray, who is responsible for end-to-end technical support of all of SymphonyAI's public sector engagements. We have Travis Barton, a data scientist on our public sector team. And we have John Polishek, who's responsible for business development at Acuity Systems, our partner on this GSA project. Our presentation will start with some background on the data analytics and AI lab used to host our software. We will then introduce you to SymphonyAI, which was responsible for executing the GSA prototype. We will briefly describe the scope of our efforts. Following this, we'll give you an overview of the EurekaAI platform that we use. The bulk of our presentation will focus on presenting the results of our prototype. We'll then conclude by describing potential next steps. Please note that we will be publishing a white paper on this project on the ATARC website shortly. A quick reminder, as Nicole said, please submit your questions in the chat box and we will be sure to address them. I will now hand over the presentation to John Polishek of Acuity Systems. Over to you, John.
Great, thank you, Raj. I think what we'd like to do is just provide a little bit of background about the ATARC lab and how this project came together. As labs is a little bit new to ATARC, a new effort, I think it's important to talk about how we got here. And I think that as you'll see, the results and the work that was done has really reinforced the value of the lab concept that ATARC is working towards. So in speaking with ATARC, as you know, many of you have probably attended many of the events over time and are very familiar with the work that ATARC does in bringing together government and industry. And what Tom Suter, president of ATARC, was wanting to do is to become a little more hands-on and take some of this work and really start to produce some hands-on events where government industry can work together on specific use cases that are relevant across both agencies, federal civilian, as well as DoD. So we agreed to partner with ATARC and provide them with our nAbleCloud Labs product as the environment for virtual cloud labs. And what we did with this is we took the use case from GSA that was provided via Ellery Taylor, who unfortunately is retired and isn't going to be able to join us to see the results of this. But he was very influential in bringing this use case to ATARC and to the labs for us to work on. And with that use case, he also brought some resources from GSA to the lab and provided the expertise to help the SymphonyAI team understand that data and to do their analysis and provide these results. Next slide, please. So the value of the labs for ATARC is that it's an open lab. It is completely agnostic as far as cloud operating systems and any software. So it provides a very nice segregated environment to do a lot of research, whether it's POCs or just demos It's a very easy way to spin up cloud environments that can be easily configured to either mimic an agency or just be a plain vanilla environment to do some research. And currently we are supporting the AI and analytics lab here today, but we've also been working with the Zero Trust lab. And I don't know if any of you out there has taken part in any of those presentations, but it has been very successful. And again, the idea of bringing use cases from government, in that case, it was from HHS, and then inviting users to show their demos and how their Zero Trust solutions would address those. Next slide, please. So as you can see, with this lab concept, it really is able to provide a myriad of different use cases and really satisfy a lot of different stakeholders, whether it's from a security aspect, from a training aspect, even doing procurement and market research. It's a very flexible environment, and we hope to really improve upon this with ATARC. And I believe that we are looking at several other communities of interest some of you may be a part of, such as the IoT, RPA, and I believe there's a DevOps lab. So hopefully you'll be interested in learning more about this and taking part in some of those other communities of interest. And if you have any other questions about the lab and how it can be leveraged for your specific use cases, I'll put my email into the chat, and feel free to reach out either directly or in the chat itself. And with that, we'll turn it over to Raj, and I think you'll be very happy to see the results of this and look forward to seeing it.
Perfect. Thank you. Thank you, John. By the way, just to quickly address the question that was posted, yes, we will be making the presentation, a recording of this presentation available on the ATARC website. So do look out for that. So here is a brief introduction of SymphonyAI. We are a vertical AI SaaS company founded in 2017 by Dr. Ramesh Wadhwani, who is a well-known Silicon Valley entrepreneur and investor. SymphonyAI's mission is to be the leading enterprise AI software company across all key verticals, leveraging a common underlying platform, EurekaAI. Our solutions address a variety of diverse markets, including public sector, financial services, industrial manufacturing, and retail. Our unique approach is based on leveraging our own in-house data scientists and domain experts. So this way, you don't have to be hiring data scientists to enjoy the benefits of AI. We have industry expertise that help us, industry experts that help us understand data availability and rethink workflows. And this helps optimize the usability of our applications and the value that we deliver to end users. We support enterprise scale, both in terms of, can you go back, please? We support enterprise scale, both in terms of volume as well as complexity. And based on these differentiators, SymphonyAI provides production-ready, packaged AI applications that are readily deployed, can be easily modified after deployment, and deliver high returns on investment. Go ahead. Our company and our products have been highly rated by a large number of industry analysts, including well-known organizations like Gartner, as well as analysts focused on specific industry verticals where we offer best-of-breed solutions. So the prototype that we built was sponsored by GSA's Federal Acquisition Service. We executed the prototype using our patented, award-winning EurekaAI platform. The prototype was intended to explore the use of AI and machine learning software to help promote the use of small businesses in federal contracts. As input to the prototype, we ingested award data for 376,000 IT contracts over a 4-year period. Our specific focus was on analyzing contracts awarded by GSA, Department of Justice, Health and Human Services, and the Department of Defense. Please note that the data that we reviewed was a collection of ITC contracts and a few other vehicles. As such, it may not be fully representative of the current state of IT procurement. And with that, let me hand it over to Eric Murray to provide an overview of the EurekaAI platform that was used to build this GSA prototype. Over to you, Eric.
Thanks, Raj. Travis, if you can go to the next slide. So Raj talked a little bit about the data there, and we all know that our data is growing. We actually know it's expanding rapidly. We've got many ways to handle this, to handle the more and more rows that we see. We use big data systems like Hadoop and Spark. We can horizontally scale and use more hardware to process that, GPUs, et cetera. But how do we handle increased complexity? All those wonderful data-rich columns and features that we see. And the issue there is most machine learning algorithms struggle as the number of columns grow. They can all handle deep rows, but width is an issue for them. So they have to use techniques like feature selection, dimensionality reduction to reduce the complexity of the data into something that the algorithms can actually handle. Now, he just talked about 376,000 rows, and I would say that that's not very big data, but your data is definitely complex. And so to understand that, we need a structured way to build models, to explore it, and to get actionable insights quickly. And I propose to you that that approach that we should use is topological data analysis, which is what we use in our platform. So what is topological data analysis, or TDA? It's actually an organizing principle for complex data point clouds that's based on algebraic topology. So you didn't know this, but I'm about to kick off a 45-minute math lecture here. So I hope you guys are going to enjoy that. For those of you who stayed here and didn't just hang up, I'm just kidding. That's about as deep in the math as I'm going to get. So, but TDA was actually developed by the head of the Stanford Math Department. He did that in conjunction with DARPA to help understand data as it gets more complex. He then went on to help found our company with the goal of bringing topological data analysis to the rest of the world. And so TDA actually, it surfaces the underlying shape and structure of this complex data for supervised, semi-supervised, as well as unsupervised problems. It actually brings to light key drivers and factors that influence the underlying behaviors of the data. And that enables us to quickly get to the root cause, to discover root causes, as well as levers that we can use to predict, influence, as well as change the outcomes into the future. Go ahead and go to the next slide, Travis. So I want to talk to you a little bit about some of the areas where our platform excels. So all machine learning algorithms depend upon shape, whether they're fitting the best points, fitting the best line to some points, like in linear regression, defining a complex n-dimensional plane or decision boundary to separate classes, or simply the number and shape of clusters. Now, most algorithms are useful for a specific problem, a specific type of problem, and that's really the goal of the data scientist, to understand when they should use those particular algorithms. But because TDA actually surfaces the shape, we can use it across all different types of problems. One example that we use, one type of problem we use TDA for is segmentation problems. And this allows us to find groups or cohorts that behave in a similar fashion across all the features. And we can do that in an unbiased way by just using, for instance, like we're going to look at in your data, contractual information. We don't have to slice and dice it by sort of demographic type terms. And Travis is actually going to show you an example of that, obviously, in a few minutes. Anomaly detection is another type of problem that we use TDA for. It's actually an added benefit in almost any analysis that we do. So I mentioned earlier that when we build these topological models, we find shapes and segments that are very similar to each other. So things that aren't similar to each other, these anomalies, these dissimilar items, they just pop out in the analysis as what we call singletons. And on this slide, the last couple cards that I want to mention are prediction and model improvement. Obviously, TDA is a wonderful solution for an unsupervised situation, but it also excels when we're trying to develop a predictive model. So one method that we often use to develop those predictive models is ensembling. And in that situation, we first build a TDA model on the data, and then we build predictive models for each cohorts, or for each one of the cohorts, sorry. And then those local models, they don't suffer from global optimization issues because they're typically learning from a population, a segment, a cohort that are much more homogeneous than the rest of the population. Go ahead and go to the next slide, Travis. All right, so obviously I can't talk about our technology platform if I don't show you an architecture diagram. I'm not going to spend a lot of time here, but I do want to highlight a couple items. First, in the bottom in the data layer, we've got the ability to connect to your data, whether that's an S3 bucket or Azure Blob, a SQL or NoSQL database, or a data warehouse like Snowflake, right? And in that layer, we can also handle database and data science transformations, as well as a feature store so that we can develop features that are specific to individual domains. As Raj pointed out earlier, we've got our deep vertical domains. And so there we develop features that were specific to the GSA. Now in the ML layer, we've got all the capabilities you expect in a data science platform: experimentation, hyperparameter tuning, challenger champion models, and of course, all the normal machine learning libraries and frameworks that you've come to expect. But it also, as you'll notice there on the left, it contains the only commercial implementation of TDA. Now, earlier on a slide, you briefly saw an example of a topological model, the graph, network graph there. And you're going to see how we actually use those in a few minutes. But you want an application and dashboard that can provide insights, right? You don't want that complex combinatorial graph that you have to explore and understand. And probably, quite frankly, most of you aren't data scientists and don't want to do that. So in the presentation layer, we've got our AI model tools that we could demo in the future, our workbenches and our irises, but also custom built and bespoke applications. And we can build those and host them into the platform using our low-code, no-code frameworks. We could also feed an existing system or dashboard that you may already have. And actually, Travis is going to show you an example of that in a mock-up later on. All right, so we're here today to talk about the GSA work that we did in conjunction with ATARC, but I actually wanted to show you and use this slide to sort of go over the breadth and variety of the types of problems that we can solve using TDA. And so there's several different use cases here. The first example I want to talk about is in the upper left, where we're performing medical research on type 2 diabetes. This is actually published work, and you see an example of the medical journal there, where we actually uncover weak signals that other techniques can't find. We actually find that type 2 diabetes isn't one disease, but you actually see that it surfaces, and you may have never seen a topological model before, but it's pretty obvious if you look at that colored graph. There's three major things going on there. And so there's actually three different subtypes of diseases, and that's actually changed the way that they treat that disease. And we've done the same type of work with asthma, and it's actually revealed that it's 11 different types of diseases. Now, if I transition to the lower right-hand corner, I want to focus on a cybersecurity threat example. And here we're using unsupervised analysis to detect new types of cyber threats in the telecommunications industry. So typically, this is typically done a system looking at logs, looking for known attack patterns they already understand, they already know how to detect and find. But what do you do when you get a new type of attack, when you have a new type of threat that's there? And so they actually use topological data analysis to identify these unknown and new threat vectors. And then finally, I'll focus on the bottom middle. And earned value management is sort of the de facto method for program performance analysis. EVM, it looks at cost and scheduling and staffing metrics to help managers understand when a program is going to have an issue. The problem with those is they're lagging indicators, and they often don't alert until it's really too late for management to do anything about it. Now, so we can take that same EVM data and we can combine that with the unstructured data from the program. So I'm talking emails, managers' progress reports, quarterly design reviews, other things like that. We can combine that with the structured data, and that provides a much better thorough evaluation of the program. And it actually gives us a leading as opposed to a lagging metric that we can use for management to understand when a problem is going to occur months in advance and get ahead of the program before it gets off the rails. Okay, now with that, we're going to hand it over to Travis, and I'll just pause and see if there are any questions before we go on and he reviews the results. Okay, Travis, over to you.
All right. All right, so I'm going to walk you through how we use TDA to extract insights quickly and effectively from the data. Something that was talked about earlier is that TDA is really good at unsupervised learning at scale. So when you're breaking into a data set and you have just this massive load of unknowns in front of you, it's a really tedious process for a data scientist to figure out what's inside. It's a lot of going back to the data, coming back with assumptions, realizing they're violated, going back to the data. And it's this convergent process that's like ping pong that's very inefficient and does not work as you grow in rows or in columns. But TDA is different. The idea behind TDA is that you make one model and then work alongside that model to uncover insights. And it's a very human, very visual process that scales because everything is mapped to these topological models. It doesn't matter if you're working with 1,000 rows or 1 million rows. It doesn't matter if you have 50 columns or like we have in here, thousands of columns. It's all the same. Now, before I get started, I want to talk about three things. First, there is no socioeconomic data used in the fitting of this model. So when these topological models are made, it has no idea of any attributes of the contracts that are involved. It does not know who is a small business. It does not know who is a woman-owned business, who is a veteran, who is an 8A. It has no knowledge of that. So any clusterings that we see of service-disabled veterans or minority-owned businesses or small businesses, that is completely unbiased to the model fitting itself. Second piece is that for my analysts, there's a powerful Python SDK that makes everything I do here accomplishable through code. I personally use the UI because I'm good at it, and it's very efficient and it's very handy. But all my coders out there, this can all be done inside a Jupyter Notebook. There's no need to use the UI if you don't want to. And for my business folks, we got plenty of pretty pictures, so that's a boon as well. That's a joke, but honestly, you'll see that this is a very visual approach that really does make it super easy for a data scientist or a business analyst or an executive to just dive in and see what's going on. It breaks down the barriers between the data folk and the business folk. And lastly, I want to say this. I am no SME. I have very little subject matter expertise in government contracts. And what's more, I've actually only been with the company about 6 months. And I say this because it's a testament of how easy this data is to use. Because with only a few weeks of work, I was able to explore and uncover insights on the data with these models. All right, so first I want to talk about the GSA. And on a high level, the GSA is doing generally well. It has a higher distribution of contracts to small businesses and the general population. It does suffer from a classic problem that we'll see throughout the entirety of the data, and that is that IT hardware contracts generally go to small businesses for low contract values on average, and IT outsourcing contracts generally go to larger businesses for higher contract dollars on average. But specifically, the GSA could stand to improve in its computer-related services. I'm talking training and coding and design and et cetera. All those are areas where the GSA can improve. Now, let's see how we use TDA to extract precise insights from the data directly for decision makers. So what you're seeing in front of you is a classic application of TDA. I have two topological models here. The same topological model, but two different views of it. You can see the shape is the exact same for both topological models. But the top is colored by dollars obligated, and the bottom is colored by small business flag, which is just a Boolean flag for denoting what's a small business and isn't. And red means more and blue means less. Now, if you can see that there is an island of small businesses, a pocket of small businesses in an ocean of not small businesses, congratulations. You can use TDA. It really is that simple. It is an extremely visual, intuitive approach. And when we actually want to discover what's going on inside this data, the resulting approach is incredibly intuitive as well. I used our UI. I used a lasso tool to select and name this group. Then I moved over to our comparisons tab and said, compare this group versus the rest on socioeconomic factors. Bam. Right away, I can decide whether or not this is something worth investigating further. Does this qualify as a problem area? And sure enough, it does. We have 30% more disadvantaged small businesses in the surrounding flare and 10x less dollars obligated. And remember, these topological models are based on sound statistical principles. So these nodes are similar to the ones around them, yet they have more small business and less dollars involved. To figure out what exactly is going on inside the business side of these contracts, it's the exact same process. I just say, compare this group versus the island on business contracts or my prediction contracts. And what I found was 1,000 IT hardware companies in a sea of computer-related services with less dollars obligated funded by the armed forces. Just as important as finding what's present. So that was a case where we found what was present in the data of a problem area. It's important to find what's absent as well. And that's another thing that TDA is very good at. what you're seeing here is the same approach. It's two views of the same topological model, one with dollars obligated and another one this time with small disadvantaged business flags, which is just a different flag we have for our socioeconomic factors. Sure enough, I noticed that, hey, there's less small disadvantaged businesses here than there are over here just by color mismatch. And there happens to be a lot more dollars here than over here, or maybe just as much dollars over there. So I lassoed and investigated. What I found is less disadvantaged in small business, less women-owned, half as many Hispanic-owned owned businesses in the population, with 2,000x the dollars obligated in the population. TDA can not only find what's present, where problem areas are, but also where problem areas are based on what's absent as well. And all with an amazingly natural and intuitive approach. And it creates actionable insights quickly and with literally no more skill needed than do these colors mismatch. Now, this last one I'm kind of excited for. I want to talk to you guys about this one because it's kind of like the coup de grace of the two that I've shown you so far. So going back to these nodes being mathematically similar, we can use certain geographies to our advantage. For example, when I see a split island like that, it instantly raises red flags in my mind. Remember, there are no, I'll say this again and again, there is no socioeconomic data used in the fitting of this topological model. So any split you see is not known by the model. The model didn't know, put small businesses over here, put large businesses over here. It just said, these are contracts that are similar, and these are contracts that are also similar, but they are more similar within, and these are more similar within. So what can we do with this? We can take these models and use them, these islands, and use them as success templates. What we have here is a model where we have a success. We have a whole island of IT hardware contracts. And that's an area where the GSA has struggled to assign contracts to small and disadvantaged businesses for high dollars. Yet here we have an example of them doing just that. We can take the insights derived from this island and use them to figure out what actions need to be taken on the other two examples you just saw. The idea that the topological model doesn't just find problem areas, but it also finds solutions as well. It finds where you're doing things right and how it can be applied elsewhere. All right, now enough about the GSA. Let's talk about the DOJ for a second here. The high level for the DOJ is that it could improve its allocations to small and disadvantaged businesses, or its contract allocation. On average, it spends twice that of the general population on contracts and has half the small business presence in the general population. One interesting fact is that the IT software is usually a category that is reserved for larger businesses, but within the DOJ, it seems to be more evenly spread between larger and smaller businesses. So that's a boon there. But overall, the DOJ could improve its dollar allocations, diverse dollar allocations. Small businesses seem to be the niche rather than the norm inside the DOJ. Now, what can decision makers do about this problem? Well, finding regions of trouble is literally just as easy as we did before. You color by your key metrics and you look for red flags. The approach doesn't change. It doesn't matter if you're looking for the GSA, the DOJ, or the all departments all together. The approach is always going to be the same for this kind of analysis. And that's one of the beauty of TDAs, that it's highly abstractable. Because we map back out to this topological pattern, to this map that is very human and very intuitive, everything falls back to those simple tools that you can use to your advantage. And sure enough, we found a region when doing the exact same process of looking for red flags, qualifying with our comparisons tool. We found a region where women, vets, minorities, small businesses are all overly present, but with 10x less dollars obligated in the populations. And these contracts are generally general computer services, and they come from various law enforcement agencies. All right, I'm gonna take a beat because this last one's kind of exciting. I like this one a lot. This is my favorite example of the three. During my analysis, I wanted to take a look at what happens if I look on a global view, if I take a look at all of the departments all together and see if there's any trouble areas. And I'm glad I did. And what you're seeing, by the way, this coloring is small business presence. So red means more small business presence. And this island stuck out to me as very stark. This is an island separated from the rest of the population that is overwhelmingly small business. And I saw from another view that it had less dollars obligated. This is gonna be another great example. Okay, so let's do exactly what we did before. Let's lasso it, let's compare it, and let's look at the qualifying demographic statistics. And when I did, I was surprised. There's no veterans, no disadvantaged businesses, no minority, no black owned, no DOT, no CERT, no 8A, no hub zone businesses whatsoever. There is actually no other evidence inside the data that says that this group should be small businesses. With no more effort than literally, with no more skill than literally saying, what is different about these two pictures? I was able to find 21,000 falsely labeled small business contracts. Now, a little disclaimer here, I don't want you all to get too excited. It looks, after some investigation, that these small businesses were mislabeled due to an internal calculation error rather than, say, fraud or something. But should that be the case in the future, the exact same process would be exactly how you find it. TDA is fantastic at anomaly detection. When things are not as they should be, they stand out on topological models. And this is an example of us finding it with very little effort and high efficiency.
If I could interrupt right there, Travis, I want to just point out, you mentioned it was due to an internal calculation. That wasn't a calculation in the TDA model. That was a database calculation as they were putting it together. So the data came in, and when it had been joined, those flags were left out, and TDA easily surfaced that error.
Great distinction. Thank you for pointing that out. That's a great distinction there. And I think it's time for some shout outs to the other departments. We've talked about the DOJ and the GSA, but a little falling action here. I want to talk quick shout outs for the HHS and the DOD. In general, the HHS is doing very good. It has great distribution of small business contracts and has an above average values in most socioeconomic categories. It does suffer from the same IT hardware, IT outsourcing problem that the whole data suffers from, but the whole data suffers from it. So it's not unique in that sense. The DoD can be summarized quickly. They're the largest presence in the training data, and they do a decent job at allocating dollars to small businesses. They are behind the general population in terms of percentage, like the percentage of small business contracts that they allocate, but they generally have higher dollar values for their small business contracts on average. And just by virtue of them being so enormously present inside the data, just even though they are behind a percent, they dwarf others in raw numbers of small business contracts. All right, and that's all I have for now. I'm going to come back later with a demo of a mock-up of what an application could look like. But for now, I'm going to pass it off to Raj to talk about some next steps.
Perfect. Hey, thank you, Travis. So here are some potential next steps that we could undertake. So as you just saw, EurekaAI was used by our in-house data scientist, that's Travis, to explore the GSA fast data. We'd be happy to license the same software tool to your data scientists and train them on how to use our software. With government sponsorship, we could build an application that is made available to small businesses. The small businesses would use this application to identify contracting opportunities in the government based on various dimensions such as product category, geography, etc. And using current spending patterns, the application would guide them towards specific spending areas that have the greatest need. As a third option, with government sponsorship, we could build an application that is used by small business offices or contracting offices. The end users in these offices would use this application to review hotspots that are identified through an automated analysis of the contracting data across various dimensions. This will help them more easily ensure the agency's compliance with the government-wide small business contracting goals. So as an example, we're going to show you an application mock-up for this application that we have talked about for small business offices to give you an idea of what it would potentially look like. And with that, back to you, Travis.
All right, so before I jump onto the mock-up, I want to give you all a preview of what you're going to see. So like Raj said, we put together a mock-up of what an app might look like to support internal decision makers on where to put efforts on small business spending in order to maximize return on investment. It's centered around two ideas: system health evaluation and decision maker support. The first is crucial for any large complex system. You need to be able to use key metrics in dashboarding to look at a system and quickly make the judgment call, is action needed? The second is crucial because these large systems have enormously complex levers. If it was as simple as just saying spend more on small businesses, we wouldn't be in this meeting with you right now. So I'm going to show you this app, and I'm hoping this app will give a clear view of how TDA can narrow down these problems. And I'm hoping to show you that it can even narrow it down to something as simple as a single department, NAICS code, subset of the contracts, and potentially give a tangible dollar value associated with the change. And with that, let's go over and hop over to that now. So what you're seeing right here, you can tell I'm shifting screens here. What you're seeing right here is the first part, the performance health dashboarding part. And up top, we have a number of tags that are just the instant statistics that you can gauge on a glance, things that you don't need require a whole lot of in-depth analysis, but instead you can just look at them and say, yep, that's wrong, or yep, that's right, or uh-oh, that's trouble area. And by the way, of course, every single thing I show you is customizable. You can switch around to whatever view. You can look at single departments. You can look at global views. You can change the year and what you're looking at. And anything that we would build in the end would be customizable to your specific needs as well. This is just what we think would be beneficial. But again, we're not SMEs, and you all know your business best. Also, one more note: while the presentation you saw before is real data, this one is approximate real data. It is based on a true story, I'll say. But I really just wanted to put it forward to show what an application might look like. So don't take insights from this particular dashboard mockup as infallible. Now, next, we wanted to show that if we know that the Small Business Administration has hard and fast goals for its contract allocation to small businesses, and we can very easily graph those for you and show you exactly where you are on your goal achievements, and then make it so that you can view them with any combination of years or department that you're interested in, with no unclear terms about where your specific group or department is on your goal towards these contracts, towards these small business allocations. Now, we also know that there's a certain geographic aspect to these contracts. And while this wasn't exactly in our problem statement, we thought it'd be interesting to take a look at the capability to show what is happening on a geographic level. Where are these contracts coming from? What values are they strong in? We can look at individual states. We can filter it further by individual departments, any kind of breakdown you want, but it's sometimes important. We got this insights from talking to a couple of the SMEs, and like Richard. Thank you, Richard, for giving us the idea to look at things in a geographic view, but it can be broken down to whatever subset of departments or states that you're interested, or years that you're interested in looking at. But this is all just health dashboard. This is all just to help you decide, is there a problem with my data? Once you decide that there is a problem, how do you find solutions? For that, let's move over to our Insights tab. Now, this looks different than what I showed you before. And what you're looking at is what's called a simplified topological model. A lot of what I did earlier with the circling and the naming and the visual approach is a very human, very easy, very natural approach. And a general thought within AI is that if it's a very easy, very human, very natural approach, it's probably automatable. And that is, those that would have used the Python SDK would have probably used auto grouping rather than manual investigation. And that's totally fine. The TDA is dynamic. You can use either or. In this particular demo, we showed what would happen if we used auto grouping to put suggested groups in front of you directly. It has all the same properties of a TDA model. You can still name your groups just like you would have lassoed your groups before. You can still look at them under different lights and see what they look like under different key metrics. They're still based on underlying TDA models underneath it. And you can do all the same skills that you would have done on this simplified topological model on the TDA model itself. But it's very helpful sometimes just to kind of skip that step and see the beneficial things right in front of you. And then on top of that, for every individual subset of the group, which we can click around and see all these individual subsets, and they break down all their own special statistics. I wanted to show exactly what I used to do the analysis previously. So what you're seeing here, this difference, this comparisons tool, that is the comparisons tool that I was talking about before. It's super easy to look at this and say, yes, we have a problem with a lack of women-owned businesses, a lack of small businesses, a lack of woman-owned small businesses. But maybe we're doing good on minority-owned flags in this particular subset. And some of the key performance business factors are this. Okay, cool. That gives me a better insight of what's happening inside the data. And then, of course, you can take a look at the socioeconomic factors on a different view if you want as well, with dollars obligated or a number of contracts. Now, this view is the view that I was using to do my analysis, but we wanted to take it a step further. We wanted to show you the automation that's possible within these groups, because once we have these groups and once we have a goal, a lot of automation is possible. So let's take a look at one of the opportunity analyses that we were proposing forward. Now, again, this is just, we're not schmies. This is just something that we thought might be beneficial. So every permutation, a funding agency, and NAICS code. So the Department of Army and this NAICS code has a potential gain of $1.1 million. Okay, how do we get that number? How do we decide that pursuing the Department of Army on this NAICS code with this subset will yield results exactly, around that value? Well, we can do stuff like this. By the way, anytime you click and investigate, this group will further break down into those key performance insights that you're seeing before, both for socioeconomic factors and for business. It's a great view. The comparisons tool is top notch. It'll allow you to very quickly understand what's happening inside the data. But how do we get that potential value? How do we show this demonstration of value in this automation? Well, we can do things like this. The entirety of the population is spending this much on when the Department of Army